Welcome. If you're here today, you're probably curious about BASF's journey towards platform engineering and MLOps. These keywords look really good on paper, but once you pass the Getting Started guide, you'll face several challenges, especially bringing these innovations into large traditional corporations and regulated environments. Certainly over the past 3 or so years, we have. So today, we'll show you our platform Argus, the design choices we took, and a couple of implementation highlights. And we, that is me, Klaus. I'm a tech strategist for digital platforms at ThoughtWorks.
And me, Robert. I'm architect for cloud-native ML and AI platforms.
So Argus is an internal developer platform for data scientists and data engineers that simplifies the ML lifecycle and allows the users to productionize models and workloads. It allows them to focus on their use cases, and we take care of the underlying heavy lifting. Argus provides self-service infrastructure on demand, services that are shared, as well as knowledge like documentation, support, and community. A little context, BASF is one of the largest chemical manufacturers in the world, and it operates plants all across the world that operate in high energy intensive processes 24/7. So inevitably, there's a lot of data, and this data can be used to use machine learning to make the production processes even more efficient and control them. But it can also be used in the lab to experiment and to develop new chemical products. But in order to do so, data scientists face several technical challenges. And yeah, our platform tries to simplify their life by providing access to these high-value data sets, by providing the compute and storage infrastructure they need, providing them with tools for continuous delivery. And the two aspects that we want to dive in today are its GitOps-based provisioning system and the approach to cloud-native security. Now, towards the GitOps-based provisioning. One of the core abstractions in Argus is the data product. We've chosen the data product as the starting point for the developer experience. So our users declaratively create their data product. They specify they focus on specifying the business logic and the custom code, and they declare the target state of shared infrastructure and services they need. Our platform can then take care of provisioning it automatically. And the outcome is the data product as the architectural quantum. So we want to decompose our use cases along the business and domain boundaries. And we don't want a more technical decomposition that is very common in other data-oriented platforms. As I said, the starting point for users is declaring their data product. And here's what this data product manifest looks like. It resembles Kubernetes manifests, not by chance. And in here, you can find all the different metadata for the product that we use for authentication and authorization. You find different capabilities and modules that this product uses in a self-contained manner, and also information regarding routing and resources and so on. So this is really the target state of the product that the platform provisions. And through the manifest, we also take care of things like versioning, feature flagging, and enabling good evolutionary design practices.
Yeah, thank you, Klaus. Absolutely, as you said, so the starting point for us is the product, and with that, the product manifest. So the provisioning system, or our GitOps platform, is responsible for taking this manifest, taking the user's intent, and creating actual resources and workloads from it. So essentially providing an environment where the business logic can live. And let's have a look at the three high-level systems involved in that process. First, there's the runtime. The runtime is where the actual workloads are executed, where the business logic is executed, where all the cloud resources live, and our Kubernetes fleet. The provisioning system is the GitOps-based system that does the, provisioning. And it handles consistency across the board and provides and then configures the hard runtime where the products can actually run. The orchestration system is a scalability layer on top of all of this that allows us to scale out operations and manage much more volume across teams, and also provide experiences kind of that hide away the complexities of sometimes formulating these documents. I mean, even those manifests do tend to carry some complexity, right? We try to hide it, but can't hide everything. So the user interfaces do some more hiding things. Here is a high-level overview, and I don't want to go into too much detail for all of this. The thing we're focusing on today is the provisioning system. You see there's a registry, which is essentially just a Git repository where the manifests are stored and updated, which gives us a nice audit trail, but also tooling that is very robust, very kind of battle-hardened across organizations for many years. The executor is CI/CD plus our internal logic, the stack, that we'll look into right after this. Last but not least, there's a catalog. So once infrastructure is created, we write the as-is state into a catalog. There are several service APIs that help us to build experiences for us, the operators or end users, but we're not diving into those today too much. So let's have a look at the stack. The stack is also decomposed into three abstractions: the context, capabilities, and modules. This is mainly done, first of all, for ease of implementation and separation of concerns, but also the stack is a multi-tenant kind of thing. Multiple teams work on this, operate on this, and these teams have different specializations, and the internal APIs reflect those specializations. Right? So first we create the security context, its networks, its identities, its groups, and all of this. After this, the capabilities represent raw cloud resources. What do I mean by raw? An empty database doesn't do anybody any good. It needs to be populated with business logic. But the provisioning of the services, how does it need to be integrated into our networks? How do I set up kind of the bootstrap permissions? All of this is very technical, very infrastructure-y. And we kind of hide that work a little bit from the more domain streamlined work, which then deals with the business logic. And this is done in the modules. And here I need to make one distinction. When I say business logic, for modules, we're talking about services like an orchestrator for MLOps, stuff like this that gets injected into the product environment. The actual product development work is obviously in the hands of the product teams, but these modules provide higher level services on top of this. So let's look at some key technologies that make up this stack and how this kind of process works. So we take the manifest, we read it, and key technologies here are CDKTF and constructs, which is, let's say, tree-like representation of the state you want to build. Why do I say tree? Graph analysis is very powerful, and you can inspect this state, the infrastructure tree, and then do many amazing things with it that make your life much easier. Another thing is you need to be very rigorous about your types. So we use Pydantic as a validation framework. There's JSON schema involved, and we really try to push hard left on validation. And code generation based on the schemas, based on the explicit type, really helps us to generate code also in upstream experiences like UIs, APIs, what have you. In the planning phase, modules announce a request, announce the need for a database, and the capabilities then inspect the tree and create concrete instances of this. But this tree inspection doesn't stop at creating instances. It's also very useful for generating reports, like which entity is allowed to access which resource, which obviously helps us a lot in compliance purposes, but also in providing connectivity information to downstream products.
Thank you, Robert. Now, the second aspect we want to dive with you into is the approach to cloud native security. And before I do that, just a little general context. At Dorex, we have a very data-driven and systematic way to look at engineering effectiveness, right? And when we do talking to the Argus users, we found that dealing with the traditional corporate and perimeter-based security that we used to have was one of the biggest sources of waste. That is due to two reasons. One, having a corporate policy documents very detached from what is happening in production and in code, with manual reviews disconnected from the actual realities, created quite a bit of waste. We have data access and data discovery relying on experts and manual approvals, increasing lead time. you can imagine, I think. Also, then the perimeter-based security with intermediate layers of proxies and firewalls when you try to cross network boundaries. That made the latency explode in interactive use cases. So we had additional accidental complexity of users adding additional caches and data transfer jobs. So we really said, okay, we can reduce all of this cognitive load and remove this waste by providing the means through the platform. And finally, this also prepares us to react to regulation much faster in the area of AI and also others. We have ever increasing speed of regulatory changes, and having a solid platform rollout allows us to react much more appropriately.
Absolutely, you just said it, right? So security really was the biggest hindrance in a lot of scenarios, and we've seen that complexity rise and rise and rise as we get more and more ambitious with our use cases, and ultimately the business impact we have with the applications running on the platform, right? So in this price, we kind of felt we didn't want to pay anymore. So one thing that was really transformational for us, that was sort of an inflection point in the design of our platforms, was when we adopted and hoisted all of these responsibilities onto the networking layer. So what we mean by that is the application code is no longer responsible for doing authentication authorization, but we introduce service meshes and some sort of custom structures that allow us to handle this on the platform level and allow the products to kind of just write their code as if no authorization or security wasn't an issue. And this really, really accelerates the development lifecycle for the user. So let's dive a little bit deeper into what this specifically looks like. So here, again, typical service mesh layout, we have a sidecar beside every product workload. The workload only communicates via localhost with a sidecar, and within the sidecar, we manage all the encryption, authentication, authorization, handling credentials if needed. One thing we use identity federation, so we actually get rid of all long-lived credentials in the product workloads. And we also have a means of interacting with the policy engine, which allows us to, on a network level, update policies as criticality of a product evolves, as regulation changes, and really having this observability on networking level is really, really powerful and accelerates our development.
Summing up, today we've seen how having GitOps with appropriate abstraction really is a way not only to simplify the developer experience, it in fact also makes it easier for us as platform operators to keep the platform evolvable. And secondly, we've seen how security can be one of the biggest sources of waste. It can be an enabler if done right through the platform, but certainly this is one of the hardest nuts to crack as a platform engineer. Robert, what do you think?
Absolutely. It's definitely been sort of the evergreen ongoing topic that sort of keeps on following you along. So solving that really accelerated a lot of use cases and also gave us a confidence to scale even more and even faster into the organization. And this is something that sort of is the main takeaway for us, right? So focus on evolutionary designs, be prepared to always needing to change, adopt to new technology trends, adopt to new environments, circumstances. So I'm really excited to see what the platform's going to look like next year, 2 years down the road, and kind of what the community brings in and what our engineering teams kind of can build on top of this. So before we close, I want to just kind of mention, if this interests you more and you want to learn more also about the product and business side of things, my colleague Haida did an, I think, excellent talk at YConf, looking at how the organization and the product side of this platform looks like.
Yeah, and then also, if you like reading, there's a new book called Effective Machine Learning Teams, where my ThoughtWorks colleagues look not only at the technological aspects of scaling machine learning, but also more holistically on social cultural aspects and so on. And with that, thanks for your attention, and we're looking forward to your questions.